Okay, today we're gonna discuss about objects like dimensions, attributes, measures, fact tables, and the relationships between fact tables and the dimension tables. Yesterday we discussed about how to identify dimension table and the fact table. If you have a question like how you want to see the data, and the answer for that one is a dimension table. As I explained you yesterday, if you want to see data product wise, then product table is your dimension table. And what data you want to see, and the answer for that one is your fact table. So you will have data for the answers like what data you want to see in your fact tables, and for the questions like how you want to see the data, in which dimension, which angle you want to see the data in your dimension tables. Okay, here we are going to discuss about few things, and before going to that, let me explain you a hierarchy here, a small hierarchy. Let me close this. Let me take the pen from here. And this is dimension table, okay, and this is fact table, let's say. Okay, using this dimension table, you can create dimensions. Using this fact table, you can create facts. Okay, and in dimensions, this is your dimension and this is your fact, or in other words, you can call it as measure group. This dimension will have, this is a table, this is the outcome of a table, right? And this one, if you select some 10 columns, all those 10 columns are called as attributes. Here the columns of fact table are called measures or facts. Okay, let me start from here. This is dimension table. With that you will create dimensions, and dimension, each column will call it as attribute. Okay, here this is fact table or measure group table, sorry, fact table in data warehouse concepts, and you can create either fact, we'll call it as either fact or measure group. And this one is called as, the columns in the table is called as facts or measures. Using these attributes, you can create hierarchies. This is the least level, these are objects you can create using a dimension table, whereas using fact table, you can create measures and measure groups. Okay, now we are going to discuss about how to create dimensions, how to create measure groups, and how to define, add attributes to that, and how to add measures to that, and also how to create hierarchies using dimension attributes. Okay, before going to that, let me tell you a simplest definition for cube. Cube is nothing but collection of dimensions and collection of measure groups and relationship between these two. It is not like you have to maintain only one dimension and one fact table as part of your cube. You can have any number of dimensions and any number of fact tables, and there should be relationship between dimensions and fact. And again, it is not mandatory that all the dimension tables should be related to all the fact tables. Few dimension tables will be related to fact 1, and few dimensions will be related to fact 2, and you will come to know when we discuss about it. Okay, now let me go back. Keep in mind the concept, the words like dimension, facts or measure groups, and measures and attributes. Okay, the first of our job is to identify the measures. Identify the dimension tables and the fact tables. Once you identify the dimension tables and the fact tables, then there is the easiest way of creating cube. Using the cube wizard, right click on cube and click on new cube, and use existing tables. That is, use existing table means the tables that are existing in the data source view, and click next. If you have many data source views defined in your solution, then you can pick from which data source view you have to pull data to create this particular queue. Okay, we have defined only one data source view, so I'm selecting that. And what is your fact table here? The fact table I have given friendly name as sales data yesterday. This is my fact table. Okay, go to next. And what are all the measures? If you see here, we discussed measure groups is one thing what you can define using fact table. So I'm selecting the measure group here. This is my measure group. Under that, I will have measures, each column as a measure. Here I can select what all I want as a measure. I don't want this one. I don't want this. I don't want this. Whatever the things I check, only I will get those things. Those columns as my measures. Next step is defining dimensions. Select what are all your dimension tables. Sales data is not my dimension table. And product view, I don't want it as dimension table. And I don't want sales data as dimension. I want only customer, product, time. I don't want promotion. I don't want currency. I want to create 3 dimensions. Okay, click on next. So here it will give the overall picture. I selected one measure group and these are the measures under that, and I selected 3 dimensions. Click on finish. Now if you see, the dimensions are created and the cube is created. In that cube I can see this is measure group, under that there are measures. This box is for measure group details, and here these are all the dimensions. Okay, and these are all the dimensions that I have, that I selected. Now it is taking only key column, but I want to analyze my data based on first name of the customer and last name of the customer. In that case, I have to drag and drop here into the attribute pane so that I can able to use this to analyze my data. In the same way, from products, I want to analyze my sales based on product name. And in time, I want to analyze my data, my sales based on month. Let's say this is a simple example and we're not going to stick to this way of creating cube. Okay. As I said, dimensions got created and measure group got created. Don't get confused here. You have many dimensions than what we created. We created only 3, but you have 5 here. Don't get confused about that. We'll come back to that. And as I defined as I've given the definition for cube, it is a collection of dimensions and measure group and the relationship between those two. Now I have my measure groups here. I have my dimensions here, and this is the place where I will have relationship between these two. This dimension and this measure group has some relationship set. Okay. Now everything is set for my cube. Now what I have to do? Now I'm going to distinguish the different. I'm going to explain you the difference between build, deploy, and process. If I click on build, it will check for syntax errors whether there are any or not. Nothing there, so build succeeded. If I click on deploy, until 2005, it was like it used to deploy only. But in 2008 and onwards, if you click on deploy, if the deploy is successful, it's going for process also. Let's see, I click on deploy. It's deploying, you can see it here. See, now it's saying deploying and processing. It's going for processing of data also. Okay, my cube got deployed and processed in the server, and this browser tab is used to check whether the data is coming correctly or not. And let's see whether it's coming correctly or not. As per my definition, cube is ready. The dimensions are there, facts are there, and the relationship is set. And this is how you can see the data. These are all the measures I selected. In other words, facts. I can drag sales amount. I can see the total sales amount. And these are all the This is the dimensions I created, and this is the English product name, the attribute I selected. If I drag and drop, I can see product name wise sales amount, giving me in fraction of seconds. And this is not the only advantage you have. If you see how you can analyze data based on your cube database, using your cube database. Okay, now I'm gonna see the product wise, customer wise sales amount. Okay, which product, which customer bought which product and how much amount he paid, how much sales I got, revenue amount I got from a particular customer. Let's see with the first name. Okay, this guy bought this product and the sales is 159 rupees. Like that, this guy didn't buy this particular product and this guy didn't, and this guy bought up for $318. Okay, like this you can split and see. If you want to see first name wise who all are bought a particular product, Aaron bought these products and this is the amount he spent. Just drag and drop simply. Abhi bought these two products and this is Abhijit. And if you want to see product name on your columns, you can see like this. Okay. And not only this, you can play with dates also. We have selected month, in which month this particular guy bought this product. In Aaron, total sales amount in January is 7997 rupees, 0.852. And in February this much, March this month, April this much, like that. So if you see the output of this cube solution, cube database, you can analyze your market and you can analyze your business like anything. It's damn fast, and you can slice and dice the data, and even you can filter the data. You can see only a particular person's data like Abhijit. If you want to see Abhijit data, you can select, you can filter and see. Or you can select 3 to 4 customers data. Okay. Now this is the simplest way of designing the cube. Now your cube database is ready. If you want to see the same data in your relational database, you have to write hundreds of queries. You cannot simply drag and drop here and there, and you cannot get the output this quickly, this much fast. Okay. So analysis service will help you in slice and dice the data and pull the data from your database faster. Okay. Now I define a way how we can create a cube, and this is not the best way of defining the cube. Let me tell you the best way of designing the cube. I'm deleting this, and I don't want these dimensions. Whenever you're gonna design your cube, first set the requirements clearly. What are all the things that you want as your measures, and what are all the things that are required as your attributes, and go through the requirements clearly given by the client, and then start designing. First categorize what are all your dimension tables and what are all your fact tables, and in fact tables what measures you want. There may be hundreds of measures like sales amount, extended amount, line cost, sum cost, XYZ cost, ABC cost. But the requirement says I want to see sales amount. In that case, you don't need all other measures, right? So prepare a document kind of things which says that what are all the tables you want to create the measure groups, and what are the tables you are going to use to create dimensions so that you will meet your requirement, and what are all the columns you want from these two tables. Once you are clear with that data, with that information, then start creating the dimensions first. Okay, now I'm setting a requirement for myself. I want to see the sales amount for a particular product. Product wise I want to see the sales amount, and product color wise I want to see the sales amount. In that case, my dimension table will be product here. You can see so many options here. Use an existing table, which means you can take the table from your data source view that is there in your data source view, or generate a timetable in the data source, generate a timetable on the server, and generate a non-timetable in the data source. So these three options I will explain you later. Let's go with use an existing table, which will take a table that is there in our data source view. Now, what is my dimension table as per my requirement? It is dim product. Let me select that. And the key column I have to select it. By default it got selected. Why? Because I have defined the key in my data source view. In data source view there is a key column, key symbol for every table. If that is not there, then I will show you how it looks. And the name column, let's come to this one later. And as per my requirement, I want to analyze my business, sales amount based on English product name and color. So I have to select these two. Now click on next. It is showing, okay, you will have product key, that is for your key column, and English product name and color. Okay, this is my product table. This is my product dimension. I have these two as attributes which I selected. Okay, this is key column, which is important, primary key column for this particular table. And remember one important point whenever you are creating a dimension based on a key column. If you have to provide a key column for creating a dimension, and that key column should not have any duplicates. If it has any duplicates or if it has any nulls, then you cannot, the dimension processing will fail. For example, if you come and see the dim product table, you will not find any duplicate columns for this particular key column. Select key from dim product. You see, it is saying there are 606 rows. If I give this thing, then it will give me this thing. So again it is showing 606. That means there are no duplicate records in this particular table for this particular column. Okay. If there is any duplicate record, then the processing of this dimension will fail. Remember that point. That is very important point while creating a dimension. While creating a dimension, most of the cases it fails because of having duplicate keys. If you have duplicate key, you cannot create dimension based by taking that particular column as your key column. Okay, now you created a dimension. This is as simple as this, creating a dimension. Here you can see the option to process this dimension and see whether the data is coming correctly or not. This is the processing wizard. If I click on OK, it will process. It's done. Once it is processed, you can see whether the data is coming correctly or not here using the browser option. You can see the browser tab here for each, for the dimension. For every dimension you will find the same. Once it is processed, then you can select the particular attribute you want to see. Let me take color. It is showing me the colors that are there in the particular table. And if you see product name, it will give me the product names. What this dimension will do, what this dimension processing will do, while processing a dimension, what happens is, if you select 10 attributes, for every attribute it will write a distinct statement and it will store the data in your analysis server. For example, I selected color as attribute. What it will do is, it will write the distinct and it will take this data and store it in your analysis service. You see that here you'll have the same data, just like the distinct of this. In the same way, if you have 10 attributes, it will write distinct query for those 10 attributes from the table and it will pull the data and it will save in your analysis service. And okay, now I designed this. I defined the data, dimension. As per the requirement, I want to see the data English product name wise and color wise. Okay, now my attributes are set. What I have to do? I have to create a cube for the same. Measures for the same. I can create the measure groups in cube wizard. For that, I have to take new cube. Instead of using use existing tables, which is the way which we have seen earlier, selecting the option create an empty queue. Next, and here you have to select the data source view on top of which you want to build your cube. If you have many data source views, all the data source views will get listed here. For example, I am creating two different cubes using one solution. One is cricket related, one is adventure works related. So I will have two data sources and I will have two data source views, and I will create two cubes, and each cube will have its own data source view, pointing to its own data source view. Next, finish. Now this is how the empty cube looks. There is nothing, no measure groups, no dimensions, and no relationships. Okay. Now if you see, I created a dimension. This is called database level dimensions. These dimensions you can see in database level. If I add this particular dimension to my cube here, then we call it as cube dimensions. Okay, the first set what you create using the wizard, that is called database level dimensions, and if you add a particular dimension into your cube, there will be, that is called as cube dimensions. And what is the difference between these things? Cube dimensions are just virtual. It will just refer to that particular database dimensions. And for example, as I said, if we decided to have two different cubes, one for cricket and one for adventure works in the same solution, then I will have all the dimensions that are related to adventure works and my cricket in my database level dimensions. But I'm gonna use only few per cube. For adventure works cube, I will take the dimensions that are related to adventure works cube. And for cricket cube, I will take the dimensions that are related to cricket cube. And I will explain that. I will try to do that and explain you by defining it. Okay, now how to add the dimension to the cube? Just simply right click, add cube dimension, and click on this. And if you feel this dimension name is not proper, it's not why you need to have them, you can simply rename it. Now this dim product or product has become your cube dimension. And if you see the properties of that, this is the product, that is the dimension, cube dimension, what we are calling as, but the ID is referring to dim product again. Okay, which is your database dimension. Now, as per my definition, the dimension is ready for my cube. Now I have to add measure groups. You can add measures in two different ways, by adding a single measure or a complete measure group. The difference between this one is, if you select single measure, from where you are getting the measures? You are getting the measures from your fact table, that is sales data in our case, and our requirement is sales amount. I click on that particular measure group added and measure got added. And if you select the option new measure group, then you have to select the table itself, complete table. For example, let me delete this and add the sales data again as measure group, new measure group. Now the table is showing. If I click on this, then all the integer decimal columns that are there in the particular table will be created as measures. Okay. Now everything is set. The dimension is created, the fact is created, but according to my requirement, I need only sales amount from my measures. I can use that option new measure to create only sales measure, or take complete sales. For example, if you want only one or two, then it's better to go with new measure. If you want 15, or how many you have here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 are there. And if you want 10 from this, and if you don't want to, then add the measure group and delete the items that you don't want. This is the easiest way if you want to add more columns as measures from a particular fact table. But our case is, we want only sales amount here. And the dimension relationship, it's set by default. You don't need to give any relationship here. Why? Because the relationship is given here. So if you don't give relationship at data source view level, then you have to define the relationship here in this particular pane, particular tab. Okay. Now everything is set. Let me process this. It's processed successfully. Now let me browse and see the data. I have that particular measure what I want as per my requirement, and color wise data I can see, and product name wise data I can see. And you can drag like this which all products are coming in black color. If you see this black, you can see here black, 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 and all. What are products that are coming in blue? You can see the blue, and each level wise. And you can drag like this, and this product coming in what colors? No colors, multicolor, not applicable, blue, 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 like that. You can analyze your data. Okay, this is how you have to set your requirement, and you have to design the cube based on your requirement. For example, now my requirement got changed and I want to see the products, I mean the sales amount based on let's say class of the product or style of the product. Okay, in that case what I have to do is nothing more than dragging this one and dropping it here and making it as an attribute. Now I drag that one into my attributes pane. This is my attribute pane, and this is my hierarchies pane, and this is my data source view pane. I drag that class column into my attributes pane and it become an attribute. And I want to see data based on model name. Now I dragged everything. If you change anything to your dimension, if you add or remove any column, then you have to reprocess the complete cube. So I'm doing the same. Reprocessed. And once it is reprocessed, then you have to reconnect. Here is the button to reconnect or refresh. Okay, I reconnected it. Now I can see the newly added attributes here like model name. We can analyze like this. A particular color product comes in which model, or it's better to drag it here, model, and color here. Bike wash comes in not applicable color, and multicolor this cycling cap. So like this. Or we drag one more, that is class. You can see the data based on the class. High class, low class, middle class. HLM. Okay. This is how you have to add an attribute, or based on your requirements, you can modify your cube. For example, if you are working on support project or if you are working on some enhancements, then the cube will be there already, and you have to add an attribute or a measure, or you have to change the functionality a little bit. Okay, and now let's see how to have different data sources, different data source views, and different dimensions and different cubes. As we discussed, I mean that one will give you a clear picture about your database level dimensions and cube level dimensions. Now I created only one data source view which has connection to my AdventureWorks. Let me connect one more which points to dot means localhost, which connects to my Cricket database. Next, I'm giving service account, and Cricket is the data source name, and I created one more data source here. And let me add some, let me create a data source view based on Cricket. Here you can see two different data sources, that is showing what are there under data sources folder. Now I'm taking Cricket data source, click on next, and for my requirement I want match batsman fact. Let me search for that. Match bowlers fact it is, and this is my match batsman fact. And I'm adding here related tables. I got some tables. Okay, fine. And cricket test. By mistake, I've given cricket test, but my wish is to give cricket. So I can rename it. This is also called, this is also a star schema one, or my fact table. This is my fact table, and all the dimension tables are related to my fact table here. Now I have two different data sources and two different data source views, and I'm adding one dimension by selecting the appropriate data source view. I want to create a queue for cricket now. So I'm taking cricket and I want to see the data, I mean run score in each match. So match is my dimension. I'm selecting the match as my dimension table. The ID got selected by default and I want to see data match wise, match name wise. Okay. And let me add one more, like, no, there is nothing else. Number of overs match or result type, who won the match. Okay. See, these are my attributes now and this is my dimension. If you see, if anyone asks you about how many database dimensions are there, then you have to say two. One is dim product and another one is match. Dim product is a dimension that is created using data, so adventure work DW data source view, and match is created using cricket data source view, table from cricket data source view. Now, new cube, I'm creating a new cube for cricket. And here, as I told you, you have to select the data source from which you are going to use the tables for this particular cube, for designing this particular cube. Okay, there is one problem. If you see, I renamed the data source view here, and if you see the properties, the object ID is still test, cricket test. Okay, and whenever you are creating or whenever you are referring to this data source view in cube, it will go by object ID. So to make both same, you have to use view code, which will give the XML part of it. Every object will be created and stored in the form of XML. So this is your XML form. If you see, the ID is still cricket test. Rename it and click on save. Okay. Now if you see the properties, object ID and object name is now. And if you rename anything, only the name will get renamed, but not the ID. If you want to change the ID, you have to go right click on view code, and then you have to change it and click on save. Now let me create the cube. I'm creating an empty cube by selecting the cricket data source view and finish. Now the empty cricket database, cricket cube is created. What I have to do? I have to add cube dimensions. In this case, my cube dimension is, oops, sorry. Here this is taking object ID, something else, match, sorry, cricket test still. So let me recreate that match dimension. Cricket match. And remember, if you create any empty cube using a particular data source view, like for example object ID for this particular cube, cricket cube is cricket, and you cannot add the dimensions which is created using some other data source view. For example, if you create a dimension using adventure works data source view, and if you create a cube using cricket data source view, then for that cube you cannot add dimensions from that are created using adventure works data source view. Match name and finish. Now for cricket cube, I'm gonna add a dimension that is match, and my requirement is I want to see the runs, only runs. So I will take one measure, and here my fact table is match batsman fact. I want to see runs. And the relationships are already set. Why? Because it is given clearly. The relationships are given in DSV. And what I have to do is, I've given the relationships properly and everything is set for my cube. I have to process it so that I can see the data. The cube processed, and now the browser will have both the cubes. If you see the perspective here, have cricket perspective, and the measure groups you can see match batsman fact. 1 second. Okay, I processed only. I'm going through cricket cube, right? I'm confused. Sorry. This is the runs, total runs scored, and this is match wise runs. If you drag and drop, you can see it. Now I'm repeating the same point again. That is very important point. For example, if you have two data source views, DSV1 and DSV2, and if you create 10 dimensions using DSV1 and 10 dimensions using DSV2, and if you create two cubes using DSV1 and DSV2, then the cube that is created using DSV1, I mean pointing to DSV1, to that cube you can add dimensions that are created using DSV1 only, not, I mean the first set of 10 dimensions. And you cannot add the dimensions, like I will show you an example here. This is AdventureWorks cube, and if you see the dimensions here, dim product is defined based on AdventureWorks DW. So these two are fine, both are pointing to this dimension, and this cube are pointing to this data source view. This dimension and this cube is pointing to the second data source view. Now for this AdventureWorks, if I try to add match, you cannot see that. You cannot add match. Why? Because this is pointing to another data source view called cricket here, named cricket here. Okay, this is very important point, which means you can get the data from only one data source view into a cube. And we created two cubes from using two different data source views, and this is the simplest way of creating cube and the best way to. Now let's discuss about the difference between database dimensions and cube level dimensions. The main difference is, by seeing this, you can easily say that the cube dimensions will be less than or equal to the number of database dimensions. For example, if I have all the database dimensions created using AdventureWorks, then in this cube I can add all the dimensions. Okay, and you cannot add into the cricket cube if all my dimensions are defined based on AdventureWorks data source view. And the one more main point here is, if you have hundreds of database dimensions, it is not mandatory that you have to add everything into your cube. You can add one or two. Okay, fine. We created everything smooth, everything went smooth, no issues, nothing. And now we're gonna do the same job. I'm gonna delete all the dimensions and the cubes, and we're gonna do the same job by modifying data source view a little bit. And let's see how we're gonna do that now. I'm deleting this match, and I'm deleting this product, I'm deleting these cubes. Now I'm left with only my data source views. Okay, and as these are tables from the data source AdventureWorks, I cannot alter this key. If you see, the option is disabled, delete logical primary key and set logical primary key is disabled. Why? Because it is set at database level, not in the data source view. But if you see this product, this is the view we created in data source view level, and hence you can change the name logical primary key. Okay, you can delete it also. Okay, now let's see The most important thing in creating an SSAS project is defining the data source view. If you define the data source view in a proper way, then it will make your job, it will reduce your headache. It will take the complete headache of selecting the data, primary key and giving the relationships and all. And I will show you what is the difference if you don't design the data source view properly, how it will impact your work. Okay. Now I don't want to keep this data, key column, primary key. That's why what I can do to remove these key columns, I can replace these tables with named query. Now it become a view at my data source view level, and I can delete this primary key. I'm deleting primary key for all the things, all the tables, dimension tables, and for that I'm converting the tables to named queries. Just to demonstrate what's the advantage of designing a proper data source view. A very good data source view will reduce your work in creating the other objects like dimensions and cubes. Okay, now that I don't want this table at all. Now there is no primary key for any table. I can't call it as table, I have to call it as named queries. For any named query, there is no primary key defined, and let it be there for my fact table. And what I'm going to do is, I'm going to delete the relationships too. I'm going to show you what the disadvantages of not defining a proper data source view. Now I don't have relationships between tables, fact tables and my dimension tables. Now let me try to achieve the same output, same requirement, that is product wise and color wise sales amount. For that, what I have to do? I have to add a product dimension first. I'm using the existing tables, and here I'm selecting dim product. The first problem is here. I have to select key on my own. Okay, this is one step extra for me. I have to select product key, and then I have to select the name column also, which is product key again. Okay, click on next. This is the routine step which you have to follow even if you have if you design the data source view in a proper way. Next, done. Here this is fine. Now I'm going to create cube. I'm creating an empty cube using AdventureWorks data source view. Fine. I created an empty cube and I selected the measure sales amount. That is my requirement, right? Here it is, sales amount. Now I'm going to add my dimension, cube dimension, that is dim product. Everything fine up to here. But if you come and see, the relationship is not set. So you have to identify what relationship suits to this one, and don't concentrate much. I'm going to give it just to demonstrate. This will be regular, and you have to select the key column, and you have to select the same column in your measure group table. So all these headache will be on you if you don't define the data source view properly. Okay, and then you can process and you can see the data. So 2 or 3 extra steps, and each step, and the main thing is defining these relationships is very tricky one. It's better to leave the headache to the SSAS server by giving proper relationships. Now you can see the data properly. And I was talking about we need to have relationship between dimensions and the facts. Why we need to have? What will happen if you don't have the relationship between dimension and a fact table or measure group? I will demonstrate that. Go to the dimension table, dimension usage, and I'm removing the relationship. No relationship means there is no relationship between these two. What it will do is, if I process this, oops, at least one should have relationship. I will demonstrate it later when we go further. Okay, for now let it be regular. There should be at least one dimension related to the fact table, or else there is no meaning for having that fact table. You will come to know when we discuss about the importance of relationships. Okay, this is very simple advantage. I mean, this is not much headache. I mean, even I can view relationships and all. See the case like time. A single time column, time key, will be related to ship date key, due date key, order date key, which means if you want to see order date wise data, then I have to join with dim time. If I want to see ship date wise data, then I have to join with dim time table. If I want to join ship date, I mean due date wise data, I want to join with dim time. And remember, this order date, ship date, and due date may not be the same. I will order today, and they will ship on next month or some day on next month, and the due date, the final due clearance, I mean, I will pay the complete amount on February or March. So the value changes. Like if they see the January due date, they won't find my data. They can find my data due date on February only. So like that, all these dates are important. And if you have relationship between dim time, and if you have many relationships, not to one column, you have many columns related to dim time. And if you want to see month-wise data, sales amount data, then what you have to do is, first thing what you have to do is you have to create the dimension. Here in this case it is dim time, and I want to see month-wise, right? So English month name, and let's take calendar quarter 2, and calendar year, and calendar semester. Okay, and I'm naming it as time. Okay, now my requirement is I want to see, I should be able to see the data based on different. Now I'm adding this time. If you see, if you observe it properly, 3 different dimensions got added. But I add only one time dimension. But here 3 got added. Why? Because this is called as role-playing dimension. One dimension at database level will act as many dimensions, many different roles. It plays many different roles in your cube. And if you come and see here, this is time, 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 but ship date, due date, and order date. And if you see the key, one is ship date, one is linked to ship date key, due date one is linked to due date key, and order date one is linked to order date key. And if you try to define the same in your SQL server, I will keep it here. Select sum of sales amount from, what is the fact table we have? This is the friendly name. I don't want the friendly name, I want the main table name. It is fact internet sales. So this is my first level data. This is the total sales amount. And now I want to see the data due date wise. Inner join dim time on dim time dot date key time key is equal to fact internet sales dot due date key. Now, if I give English month name, then it will give me due date wise. Sorry. Let me maximize this. Okay, I am using that one in that, so I have to maintain group by. This is aggregated column sum of, and I am using a textual column here, so I have to keep that one in group by English month name. If you see this is giving me due date wise data. Now if I change this one to ship date wise, then this is ship date wise data, and you can see the difference. There will be some slight difference. Due date and order date. For February, the amount is 2420168. Here, due date wise, it is 2427272, and the third one, order date wise, it is 250. So the requirement may be like this: I want to see due date wise data, sales amount, all those things. In that case, you want to achieve the same. What you have to do is in single query, create alias a dot time key and a dot month name, which means this one will give you due date wise, sorry, ship date wise, and I'm gonna add the same again. This time alias b, and b dot time key is equal to this dot due date wise, and creating one more alias for the time for the table dim time. C dot time key is equal to order date wise. Now this is I'm giving A away, so this is ship date wise. If I give B, it will be due date wise. So like that, you are creating alias for the same table. In the same way, you are creating alias for the same dimension. Okay, 3 different aliases you created, and these 3 differences, it is each one referring to that particular column. Ship date in this case, order due date in the second case, and order date in the third case. If you see, ship date, due date, and order date. So this is how the role playing dimension works. There will be only one dimension, and it will create 3 different roles here in your cube. Now I created, this is fine, it is working fine. Now let's see the disadvantage of not having the relationships here. Okay, I'm creating the dimension again. English month name voice data, I'm gonna see as per my requirement and finish. And here in cube, I'm gonna add the dimension. As there is no relationship between these two, it will add only one dimension. It doesn't know how many roles it has to play. If you give relationships in your data source view, then it will identify how many roles it has to play, and by default it will take all the roles. How to configure, how to get the same output, or how to achieve the same output when the relationships are not defined at your data source view level. Let's see. Now you created one dimension. Let's say this is for ship date. Just rename it and add one more time and name it as due date, or whatever name you want, you can give that, and add it again for order date. You can rename it and order date. Once this is given, then you have to come here and you have to give the relationships and how this is related to key column. Sorry, not this one, this is related to time key. And in measure group table, you have to select properly. This is for ship date, and hence you have to select ship date key. And the next one is for due date. So go for regular relationship and don't bother what is this regular relationship. I will explain you. And you have to select due date key. And in the third case, it is for order date. You have to select this regular relationship and order date key. Now this is same as the old one, the one which got created when the relationship was given in your data source field. Now let me process this. Close. And let me browse that. I'm reconnecting it as I reprocessed it. I want to see due date wise. Sales amount, this is my sales amount. January, this is the sales amount. And order date wise, I can see. And you can drag it here. This is the sales from January. And this January, this is the sales. February, this January, this is the sales. Like that. You can play like that. And now let me demonstrate what's the difference or what's the problem in not having the relationship. Now I can remove this relationship to demonstrate that. Why? Because this fact table has relationship to some other dimension table. That's the requirement. A fact table should have relationship to at least one dimension table. That's the requirement, or else you cannot process it. Okay. Now I remove the relationship between product and the measure group. Let me process it and show you the result, how it looks. If you click on browse, reconnecting it, this is the sales amount, and let me drag the product. You see, for all the products it is showing the same sales. What will happen is it will create the sum of sales first, and it does not know how these two are related, as I have not given the relationship. So what it will do is, this is the output of English product name in the product dimension. If you come and see here in dimension, you can clearly see that this is the list, and this is the output if I don't drag this English product name, sum of the measure. So it will place this measure output, I mean the duplicate value for all the dimension members that are coming. And you know this is called as attribute, English product name. Okay. The value of each attribute is called as member. This is a member, this is a member, this is a member. Just remember the word members. Member means it's a value of a attribute. Okay. This is how the data looks if the relationship is not given, and if you get an error or a bug saying that it is showing duplicate data for all the products, same data for all the products, then blindly go and check in your dimension usage. And this is how to create different dimensions, products, measure groups, and giving the relationship between these two and browse the cube and how to see the data that is coming in the cube. And this is how, you know how to define role-playing dimensions, also called as confirmed dimensions. And let's discuss about hierarchies and dimension usage after a quick 5 minutes break. Catch you after 5 minutes. Okay. Now we're going to discuss about hierarchies. And before going to that, let's discuss about some properties of dimension. It's not mandatory that you have to know all the properties that are there in the dimension level. Let me explain few things like, okay, here anyhow I'm not going to use product key. Okay, in that case what I can do is I can set this one to visible to false. If you select that attribute and if you click on properties, F4, this properties wizard will get open, properties window will get open, and if you see this property attribute hierarchy visible, you can set it to false, and if you process it while browsing the cube, you cannot see that particular product key. And let me show you that. Reconnect it, and that key is not visible. Correct? In the same way, there is one more property very much similar to this, that is attribute hierarchy enable, the second one from the top. This one is very tricky. For example, you have 3 to 4 measures. Okay, 3 to 4 attributes, and in this case, you don't need to see the data French product numbers. You can make it as visible to false. You cannot, end user cannot see that. But why I have to process? This dimension is very small one, so if I write select distinct from French product name from product, I will get some 50 or 100 or 200 or max 600 records. So it will happen quickly. Imagine a table on which using which I created a dimension and it has 5 crore records. If I write distinct query on top of a table which has 5 crore records, it will take 15 to 20 minutes. So it is time waste one. In that one, I don't want to show this and I don't want to process this. So if you don't want to process this, you can simply delete it, or you can change the enable to false. If you see, this is disabled. If I set it to false, the icon is grayed out. And why I have to disable when I can delete it? The main reason is people uses .NET code to enable and disable these attributes in few cases. Okay, based on if they're designing the queue for French users, then they will simply enable this and disable the English product name. So in that case, using .NET, they're gonna just change one property that is enabled to false or true. So it's better if this is used by some other users and not if you don't want to process it now, and if you want to give it process it when you are giving access to French users, then keep it as disabled to false. Okay, if you process it now, this one won't process. It won't run distinct query for this French product name. And if you see this attribute hierarchy folder, this is just the user-friendly option, how these attributes have to be categorized in the queue. For example, I have French-related attributes, and these two are French-related, let's say, and this is English guys related. And just giving an example, the first one I set it as English, second one to French, and third one to French again. And this one I set visible to false, so I cannot see that. Let me enable it so that I want to see, and let me process the cube now and see how it looks. Sorry, I clicked on wrong button. Now if I click on reconnect, I can see two different folders created. Under English one, I can see the attributes for which I have given attribute folder name as English, and here the attributes for which I have given the folder name as French. This is useful for categorizing the things, and useful option only. Whenever you have so many attributes, and if you want to categorize like English related, French related, or based on some other criteria, if you want to categorize, you can make use of that. And that's one useful property. And do it hierarchy. Let me order it by name. Display folder to fully optimize like this. If you give it as order, while processing, it will order the data. It will write the query, select distinct English product name from dim product, order by English product name. It will order and it will get the data. That one will help when you are retrieving the data. You don't need to order again when you retrieve the data. It will be already ordered. And it is not, see, by default they set some values for each and every property. Whatever the value they set as default is the best option if you don't know what to do with that particular property. And default member, this one will help when you are working on MDX, not now. And you can give some description here. And estimated row count is a dummy one, not an important. And bucket count and discrete bucket method. It's like it will create a bucket. If you have 55 crore records in a particular column attribute, then it will create buckets. Like let's say you have numbers, keys from 1 to 5 crore. Then if you define it as bucket count 5 and some algorithm for that one, then it will create 0 to 10 lakhs into 1, 10 lakhs to 50 lakhs into 1, 50 lakhs to 2 crore into 1, like that. It will create a buckets kind of. When you try to access a particular value, then it will go to that particular bucket and it will get the data. And is aggregatable. This is very important one. If you see this, you have all on top, which means it will roll up and give the sum of all product data. Let me show you here in the queue. Grand total is this one. And there is no relationship between these two, right? Let me check the relationship. If you see, all is there, under that all the products are there. Which means if you drag a measure, it will give product-wise data and at the same time all aggregated data. If you set this is aggregatable to false, then it won't aggregate. That all will not be appeared. Let me process this here at dimension level. Is aggregatable is to aggregate the attribute data. Now when reconnecting, you can see that all is missing here. That's the advantage of the product or the property. And order by naming template and all other things are not a mandate and a useful one. And one important property here is key columns. Key column, name column and value column. If you are aware of drop down list, okay, if you select, while applying for jobs, if you register in any job site, job portal, you can see which country you belong to. If you select country, then it will list all the states. If you select the state, it will list all the districts. If you list all the districts, then pin code, something like that, it will list. So when you select the country name, it won't send the country name to backend to fetch the states. What it will do is it will have a value column behind it. Like for country India, value may be 27. For country Pakistan, 26. So when you select Pakistan, it will send 26 to the backend. So it will run the query like select star from states where country ID is equal to 26. So it will fetch the data. So the value that is visible to us is one thing and the value that is behind is the other one. In the same way, the key columns is the one that is behind. You cannot see that. It will process, it will query the data based on this key column and it will display the name column. If you don't define any name column, then by default it will take the key column as the name column. Okay? And if you have more than one key columns, you can create composite primary key. If you use more than one as your key column to provide uniqueness, For example, two columns will provide uniqueness to your table, composite primary key in SQL Server concepts. So if you select two columns here, then you have to select name column. Why? Because it doesn't know which one to take. Which one to take as name column. That's why it is throwing error here. You see this? The name column should be defined because there are two key columns. So remember, if you select only one name column, one key column, then by default, and if you don't select any name column, it will take the key column as the name column. And if you have more than one key column, then you have to define the name column. Okay, I will demonstrate an example for this one now. I'm creating one more product table. Product dimension. Here I'm selecting the key column, product key, and I'm selecting the name column. I can select product key, or I can select product name or any other column. So in this case, I don't need one more column. This one is enough. Product one is the dimension name. I have only one, that is product key, and if you see the properties of this, the key column is product key and the name column is English product name. I selected when I was creating this dimension. Now let me process this, and I will show you the difference between this attribute and the other attribute in other product dimension. Okay, this key called product key and this product key are same in all the aspects except this name column is same as key column. Correct? This product key is same as the product key what I created now, but the name column I have given as product English product name for that. So in this case, let's see how it appears in both the cases. I'm reconnecting it and I'm selecting product key. So I can see all the keys here. But in product one, I selected name column, English name as name column. So it won't show me the keys. It will show me only the names of it. Why? Because the name column is English product name. So what is the advantage of this? The main advantage is why I have to have two attributes like product key and product name. Anyhow, I'm not going to use product key for my analysis. So I can give name column as English product name and I can delete one. Okay. And these are all the properties at this level, and let's discuss about hierarchies. People say there are many kinds of hierarchies like natural, unnatural, ranked, and user hierarchies, system defined hierarchies and all. But for me, there are only two types of hierarchies. One is natural and another one is unnatural. What is hierarchy and why we need it? Let me add all these columns. As attributes. Okay. When the data is hierarchical in nature in your database table, then you can create a hierarchy. What is meant by hierarchical in nature? For example, if you take year will have what? Semesters. And year will have only 2 semesters wherever you go in the world. And a semester will have only 2 quarters, and a quarter will have 3 months. This is hierarchical in nature. So instead of dragging year, then quarter, semester, quarter, and month to analyze the data, you can create a hierarchy for that. Calendar year, calendar quarter, semester, calendar quarter, and English month name. Okay, now I created a hierarchy called, let's call it as calendar hierarchy. This is calendar year, semester, quarter, and month. Now I created hierarchy for time, just time. But if you come and see, the same thing will be created for all the three role-playing dimensions. Why? Because it is just referring to that. It is just a virtual dimension. Now let me process and show you the advantage of having a hierarchy. This is natural hierarchy. Why? Because this is natural. I mean, everywhere in the world, the same hierarchy followed by all the people, all the machines also. Now, if you come and see here, if you want to see year-wise, semester-wise, quarter-wise sales data of shift year-wise, then what I have to do is, oops, something happened. Why the data is not showing? Did I change any property which will impact this? I think English monthly. Is agreeable. I change it to false. It's fine. Let me refresh. Let me delete this. I think I changed some properties. Change some properties for that. That's why it's very good. Now, if I want to say calendar year, semester, and quarter, which is regular, I mean routine one, people love to see, then I have to drag these four one by one. Correct? To see year-wise, semester, this semester data as well, and then quarter. Okay? You have to drag four different attributes to see the same. And instead of that, if you define a hierarchy, you can use this. To drag this, you can directly access the data of different levels. This is just a simple use of creating hierarchy, and the main use is when you work on MDX queries, you have so many functions given by Microsoft to access data from hierarchies. You can easily navigate between different levels of the hierarchy to pull the data. To get the same year level data, if it takes more time, you can easily get that using hierarchy, if it is in hierarchy using MDX queries. And you will come on and let's bother about how to create hierarchy here, nothing much. This is natural hierarchy, and for natural hierarchy, this warning message you can see, attribute relationship do not exist between one or more levels of the hierarchy. This may result in degrading the performance of cube processing, which means it will take more time to process the cube. So how to avoid that, and what's the disadvantage of having this, not having that attribute relationships? If you come and see here, I created all the dimension attributes will be here under the key column by default. So while processing every distinct query, it will go key level. Okay. Now I created hierarchy using these four. Everything is referred still to the key column. It will go to key level to get the data. For example, to get, while processing the cube, to get the semester-wise data, what I have to do? Select semester, comma, sum of sales from fact table, inner join this timetable on so and so, group by semester. It will give me some 8 or 10 records for 4 semesters, 4 years, 8 records. But if the relationship is like this, then to get this data, what it will do is it will add all the records and then it will fetch me the data. Okay. For calendar semester, it will go through all the 50 crore records. For calendar year, it will go through all the 50 crore records. For calendar quarter, it will go through all the 50 crore records. If you have 50 crore records in your transaction table, and for month, it will go through all 50 crore records. What it is saying is why you are going through all the 50 crore records every time. When this month, if I have 12 months data, can't I get 4 quarters data? If I have 4 quarters data, can't I get 2 semesters data? If I have 2 semesters data, I can get the year data, which means this one will go through all the 50 crore records and this one will go through only 12 records and this one will go to only 4 records and this one will go to only 2 records, which will improve the performance. While processing, instead of going to distinct sum of queries for all the 50 crore records, it will go through. So that's why you have to give attribute relationships. Okay, how to give attribute relationships? First of all, you have to identify how the data rolls up. The key column will roll up to month. Fine. Month will roll up to quarters. So you have to drag this month and drop it on quarters. And quarter will roll up to semesters. And semesters will roll up to years. So you have to drag and drop. And if you see this, the warning message is gone. The attributes are properly related. So here you can see English month name roll up to quarters. This quarter roll up to semester. This semester roll up to year. Sorry, I modified something here. While dragging, I changed some. I deleted some attribute. Calendar year, quarter, I deleted semester. Okay. This is how you have to define hierarchies and give attribute relationships. If you don't give attribute relationship while processing each and every attribute level of the hierarchy, it will go through the leaf level or key column level, which if you have more data in your transaction table, then it will take hell of time to process. So better to give. See, imagine this one goes through 550 crore records taking 5 minutes. And this one will go through only 12 records, which will take not even a second, which will save you 15 minutes of time. This one will save you 15 minutes of time and this one will save you 15 minutes of time while processing the queue. So I'm giving a rough time. It may not take 15 minutes. It may take 1 or 2 minutes. Even that is more valuable to us. Okay, this is how you have to define hierarchies and you have to give attribute relationships. And if you process this, according to me, it should fail. That's it. Okay, if you see the error, a duplicate attribute key has been found when processing the dim time calendar semester value 2. So what it is saying is while processing the calendar semester, it found some duplicate key. Why? Because I'm giving a hierarchy and saying that a particular item will come under particular one. For example, if the calendar semester for 2002 year, the calendar semesters will be 1 and 2. For 2003, it will be the same again 1 and 2. For 2004, it will be the same again 1 and 2. Under which it has to take. Understood? Under which year it has to take which one belongs to which year, which two belongs to which year. So you are having duplicate keys. In other words, when you create hierarchies, you will face this problem. Why? Because hierarchy means you are gonna define that a particular quarter or semester will fall in under particular year. You have to provide uniqueness. I'll show you an example. You have under year 2002, 2003, 2004 and 2005. Sorry. You have semester 1 and 2 and 1 and 2 and 1 and 2 and 1 and 2. So which two should go to which one, and it treats as these are duplicates. Okay, if you define a hierarchy, for 1 year there should be only one set. So what people will do is, in database level, they will create 2002 first semester, 2002 second semester, 2003 first semester, 2003 second semester. Like this they will define. So which is providing uniqueness to this particular value. So instead of providing in database level, you can provide it the same in cube level also. How? Let's see. Here no problem, it will have unique data. If you come to semester, you can provide the uniqueness by going to the properties and giving the key column as calendar year and semester, which means while processing it will become 2002 1 and 2002 2 and 2003 2, something like that. Now I use two columns for this key column, and hence I have to give name column, or else it will throw error. What is my name column here? What name I have to show? I have to show semester. And now I have to provide uniqueness to the calendar quarter. I will do the same way. 1, 2, 3, 4 will be repeating for every year. So it should not happen. So I am taking year as the first one. So it will be 2001 1, 2001 2, 2001 3, 2001 4 kind of. And the calendar quarter, and in the same way English month name should be year and month. The same thing will be repeating here also. It's not mandatory that you have to give year. It purely depends on. In this case, year suits better. That's why I'm giving year. Now the uniqueness is provided. And let me process this. So it's completed. Now the warning message is gone and the hierarchy is created successfully. Understood how to provide uniqueness and why you have to provide uniqueness and why to give attribute relationships. Attribute relationships will improve the queue processing time, will decrease the time taking for processing the queue, and this uniqueness you have to provide as the duplicate keys will be formed when you create the hierarchy. While processing, it will treat that calendar year 2002. If it has semester 1 and 2, then it feels that this 1 and 2 should not be there under any other year. In the same way for quarters and months. Okay, now we created hierarchies, we created attributes, and we created measures. As we discussed, we have done 90% of the cube, like creating dimensions, attributes and hierarchies is one task, and creating measure groups and measures is one task. And next thing is giving relationships. This is the heart. If you don't give relationship, you have seen what will happen. It will give just dummy duplicate data, and the end user cannot do anything. The end user cannot analyze anything about his business if the relationships are not properly given. So this is very important concept, and we are going to discuss about this in next class, that is same time tomorrow. Thank you. So now this is natural hierarchies. Okay. Now let's see what is unnatural hierarchies. This is hierarchical nature, and everyone knows that. And there will be few people create hierarchies for making their work easy when they are running MDX queries, but in real those won't be hierarchical in nature. If you see days of manufacturing, finishing goods, and English product name, these may not be hierarchical in nature. Just simply they define hierarchy for that to access it. So these kind of things are called as unnatural hierarchies. Okay, when there is no proper attribute relationships between the levels of the hierarchy and the data is not hierarchical in nature, then we call it as unnatural hierarchies. That's it.